So as the Mercury revolves around the Sun, or as Venus revolves around the Sun, we see it at a different distance from the Sun at different times of the year, just like in that overhead that I had before. Let me just show it again. Okay? So as they move Mercury and Venus around the Sun, we see them at different distances from the Sun, right? A different angular distance from the Sun, if you will. So we see them at the largest angular distance when the line joining the planets, say Mercury and the Sun, and the line joining the Earth and the Mercury forms a right angle, 90 degrees. The same in the case of Venus. We see Venus at the largest angular distance from the Sun when the line joining Venus with the Sun is perpendicular to the line joining Earth and the Venus. So when this angle here is 90 degrees. So one can measure the angle at which we see the Mercury and Venus when they are at the largest angular distance from the Sun. In the case of Mercury, it is 28 degrees, and in the case of Venus, it's 47 degrees. You cannot see Venus at the angular distance from the Sun that is bigger than 47 degrees. It can only be smaller. Say if Venus is located here, then this angle is going to be less than 47 degrees. So once you have a right angle triangle and you know you can measure one angle, like here 28 for Earth, Mercury, Sun triangle. You know the other angle, which is 90 degrees, and then you know the proportion in which the two sides of the triangle are, based on similar triangles. Because similar triangles are triangles of any shape that have all the angles that are the same. That is, their sides are parallel to each other. So if I have these two triangles with identical angles, and I have three sides on one of them and three sides on the bigger one, right? Then I know that the corresponding sides are in the same proportion, right? And A over C is going to be the same as big A over big C, and so on. So basically, once you measure the angle in a right angle triangle, you can find out the ratio of the two sides. You can find out what is the ratio of the distance between, say, Mercury and the Sun and Earth and the Sun. So you can determine the relative distance of Mercury from the Sun with respect to the Earth Sun distance. All right? So here is a diagram that illustrates what I've just mentioned. Okay, you can see Venus at 47 degrees or less, and you can see Mercury at 28 degrees or less. And because you know that these angles here are 90 degrees, the triangles are completely determined, and you can find out what the ratio of their sides is. So then whatever the distance between the Earth and the Sun, and at the time of Copernicus and earlier, they didn't know what that distance was. Nevertheless, you can say what fraction of the Earth-Sun distance is the Mercury-Sun distance. You can also find out what fraction of the Earth-Sun distance is Venus-Sun distance. And that's already a lot. You can compare the distances of the planets from the Sun.